All right, you have made it to topic 10's review today. So we are still working with analyzing data and interpreting it. All right, so what we're going to do today is I've gone through and looked at our test that we have set up, and I found the questions that are very similar to the test questions throughout Agile Mind. So what we're going to do is we're going to focus on these questions and make sure we completely understand each question so that we'll be 100% prepared for our test that is coming up tomorrow for topic 10. So while we're going to get started, we're going to start with the guided practice questions. And we're going to go ahead and get started on this first one. That's a histogram. So Devin, yes, sir.
I was going to answer the question.
Well, I want you to read it, and then you can answer it, but you're going to have to do some explaining at the same time.
Yes, sir. Consider the histogram. In which interval would you expect the median to be located? I would say the interval 0.4 to 0.6. And the reason I say that is because, like, when you look at it, it looks like half the data is on the left side of that and half the data is on the right side of that.
All right, so to the left of that, looks like we got about 50%, and to the right, okay? So if you didn't know what the answer was, what's something that you would know that it couldn't be and why, Angel?
What's the question? I'm charging up my computers.
All right, Alora, if you didn't know that the answer was 0.4 or 0.6, and you were trying to eliminate answers, what's one that you could eliminate and tell me why?
I could eliminate 0.0 to 0.2.
Correct. Tell me why.
Because it's the maximum, it's the minimum, and it's not really in the middle.
So the median means the middle of the data, right? You did a great job explaining that. Good job. So back at Angel, what's another one you could eliminate and why?
1.8 to 20. 2.0
right,
or whatever.
why?
Because it's the minimum.
Well, it wouldn't be the minimum. The minimum is the number that's the smallest in the data.
Oh, maximum.
But it's getting close to the maximum. The maximum would actually be located right here. But it's definitely not the middle of our data, is it? Since it's so far to the right, it can't be in the middle. So that's how we know it's not right. And 1.6 and 1.8 are actually right beside it. And so we know that the middle of our data should be somewhere in this area. So if it's not in this area, then it cannot be our median. So the best possible answer was what Devin said earlier, which was what, Devin?
0.4 to 0.6.
Good. Does anybody have a question about that? Good deal. We're going to move on to our next question, which is question number 3. All right. Would you read this one for us, please, Sophia?
The median of this data falls in the interval from 0.4 to 0.6. The mean is the balance point of the histogram. In the data, the mean would be to the left of the median.
All right. So remember, we had the balance beam was our mean, okay? Now, so this is like having some weight over here being equal to something on this side, okay? So it says the mean is the balance point of the histogram, and in this data, the mean would be to the left of the median. So if we put the mean on this side, and this is on a balance beam. What's going to happen, Sophia, if we move that balance point all the way over to the left like I just did?
It's going to be unbalanced.
Yeah, it's going to be unbalanced. It's going to get tilted like this, right? Wouldn't it be something like that? So, can this be true?
It has to be false.
Has to be false. Could not work because it would not balance out, because it would be too far to the left of the middle of our data, and then that would make it where it was unbalanced. So go ahead and read that down there at the bottom, Sophia.
Great. There are values far to the right of the median. If the mean were to the left of the median, the histogram would tilt down.
Correct. All right, looking at our next question. Tamarian, I want you to read this.
It's still loading for me.
That's okay. Which of the following are true statements about the data represented in the histogram? Select all that apply. The mean is less than 1 inch. One day it rained much more than all the others. It never rained exactly 2.5 inches. The mode rainfall is between 0 and 0.2 inches. And it rained between 0.4 and 0.6 inches for 8 days in a row. What do y'all think?
I would say the first one is probably right.
All right, let's talk about why it could be right. What are you noticing that makes you think this? The mean is
Because
the what?
The mean is the balance point.
It is the balance point, and it's also known as the average.
Average.
Good. Okay.
The reason that I think the mean would be there is because sort of like most of the data is on this side, and like the almost about the same amount of data is on this side. Like there's the same amount of data on each side.
Okay.
On each side, if it's less than 1 inch.
Okay. So in other words, it looks like there's less data to the right of 1 than there is to the left of 1. Is that what you're saying?
Yes, sir.
Yes. So that means that the average of the data should be less than what?
1 inch.
Good. All right. Next thing that it says is one day it rained more than all the others. Is that true or false, Akira?
Is it floss? True?
I don't know. Somebody help her out.
It looks true to me.
True.
So if we look right here, we should be able to tell our answer, Akira. So
It's true.
It is true because one day it rained almost 3 inches. All the other days were 2 inches or less, right? So isn't 3 inches a lot more than 2 or less?
Yes.
Yeah. So that works. What about it never rained exactly 2.5 inches? Brooklyn, is that correct or false? Did it ever rain exactly 2.5 inches? If it did, it'd be somewhere in here. Do we see that on there anywhere?
No, sir.
No, we're not seeing it. So that has to be correct. Vincent, the next one says the mode rainfall is between 0 and 0.2 inches. Remember that the mode is what is listed the most in the data set. Do we have the data set? Do we have the data set, class?
No.
No. So can we know for a fact that the mode is between 0 and 0.2?
No.
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 Let me explain why. It could be 0. Since it says between 0 and 0.2, that's not, does that include 0?
No.
No.
It includes 0.1 to 0.2.
Correct. All right. And so it's kind of, without having the data set, we just don't know. It's not enough information for us. Now, if it would have said the mode is from 0 to 0. Is the mode could be from 0 to 0.2 inches if looking at the intervals, then we could say yes. But that's not the case here. So that's out. Next one says it rained between 0.4 and 0.6 inches 8 days in a row. Well, when we look at 0.4 and 0.6, it is at 8. But this says 50 wettest days of the year. Does it say days in the row?
Yeah, it doesn't say like they're in a row.
Correct. So
that's 8 days out of an entire 365.
So we don't know. So that is going to be wrong as well. So it says the days are cumulative. So it rained between 0.4 and 0.6 inches for 8 days, but not necessarily in a row. We cannot tell the mode from a histogram because we need the what?
Number set?
Yeah, we need the data set or the number set. Good.
Data set.
All right. Looking at this one. What do you see here? Let's go with Natalia. I want you to read this.
The principal tells the Environment Club that he appreciates their attention to the science of temperature and rain, but he wants to see data on how often students would use the greenhouse. They need to conduct a survey. Which of the following would give them a simple random sample?
All right. So is a simple random sample, is that something that only refers to like our classroom, or is that talking about like everyone?
A random sample of the entire population.
Correct. And so since that's the case, what do we need to do?
Can I say it?
Yeah, go ahead.
Have the school's computer generate a sample list of the students' name using a list of all the students.
Good job, Braden. So Braden, tell me this. Why would it not be ask the members of their club?
Because that's a group. It's not the whole population.
Good. Why would it not be this, Brendan? Going to each person in the art class. Why would it not be that? Somebody help him out.
Because it's still a population.
It's just a group.
It's just a small group. What about everyone in the 9th grade English class?
That's not including the whole population either.
No. So all 3 of these are considered what? Bias data. Meaning that it's opinionated. Okay? It's only dealing with one certain group of people. It's not dealing with the entire population. You're not representing everyone. So for it to be a simple random sample, it needs to represent who?
The entirety of the population.
Yes. So that's important. Everything that I'm writing down is very important. All right. Rachel, I want you to read this for us.
Here are the box plots from the Student Council and the Environmental Club. Which of the following are the correct comparisons? Select all that apply.
All right. First thing I want y'all to understand is that a box plot represents 100% of the data. A box plot is broken into 4 parts. Okay? I'm going to show you those 4 parts. So the first is from the minimum. And everything that I'm writing down, I want you to write down right now. To the lower quartile. And this makes up how many percent? So I'm
25.
Correct. So I'm talking about right there. %25. All right, the next one that I'm going to talk about is here. And that is from the lower quartile to the median. And how many percent does it represent? Think about
25.
it. Correct. 25%. Next one that I'm going to talk about is here. Which is from the median to the upper quartile. Once again, everybody needs to be writing this down. And it also equals 25%. Now there's still one more section, and it's right here. And that is from the upper quartile to the what?
Maximum.
Yes, to the maximum. And what does it represent?
25%.
Correct, because altogether it makes up what?
Excuse me, teachers, please.
100%.
All students that ride bus 87 will ride bus 52. All students riding bus 87 will ride bus 52.
Sorry for all of y'all that are watching this as a recording. All right, so with this being said, something looks weird over here. I don't see a whisker. I don't see a minimum. Who can explain this?
The minimum, the lower quartile are the same value.
Correct. The minimum and the lower quartile are both what?
0.
0. So in case you ever have anything strange that shows up like this one, everybody needs to understand that this is the median. And everything to the left of the median would be 50% of your data. Everything to the right of that median, which is number 1, would be 50% of the data. So now we're going to actually answer the question. We're looking for all of the correct comparisons. So it says the multipurpose track has a higher median number of hours per week than the greenhouse. Is that true or false?
That's true.
It is true. The median for the multipurpose track is what?
3.
And the median for the greenhouse is
1.
1. The minimum value for the track is higher than the minimum value for the greenhouse. Y'all are taking a little while, but it's false.
No.
All right, because they're both what?
0. It's the same.
Correct. For those of you that are confused, that right there is the minimum. The multipurpose track has a larger range of responses. So we're talking about
correct.
from the minimum all the way to the maximum. And so Devin said this is correct. Do y'all agree with his statement? I do. All right, because 0 to 12 is more than 0 to 5. 0 to 12 is 12. 0 to 5 is 5.
5.
And 12 is greater than 5. Next one, the multipurpose track has more total responses to the survey. Do we know the number of responses?
No, it doesn't tell us. It just gives us the data points.
Correct. So a box plot does not tell us how many responses. It doesn't give us enough information to get our mean or our mode either. All right. So this would be wrong. Oh, my Lanta. There we go. Most of the respondents to the greenhouse survey replied they would use it more than 2 hours per week. Well, when we looked at it, 2 hours per week is here. We said that the median, that is right here, splits our data at 50%, right?
Yes, so wouldn't that be incorrect?
So if this is 50, then that would be 25. So the only thing that's more than 2 hours per week is right there, which is only how many percent?
25. So 75% of the people actually would use it less than 2 hours a week.
Correct. So that is wrong. Anybody have a question about that? Everybody get their notes taken down. Going once.
Yes, sir.
Going twice. It's out of there. And now we're going to our more practice. Satari, I want you to read question number 6 for us in just a second.
Yes, sir.
Go ahead and read that one, please, ma'am.
This box plot displays a summary of Angela's math homework grades for the last grading period. What do you know about her grade slate? All that apply.
All right, Satari. So what we're going to do is, before we look at anything down here, I want to focus on this. So what we're going to do is we're just going to break it down. What is the lowest grade she's ever scored? Good. So the lowest grade she ever scored was a 20. What about the median? What's the middle of her scores?
60.
80.
All right, we got a difference. Let's try to figure out why we got a different answer.
I don't know if it was right, but I thought I said 60.
All right, so 60. So this would be our minimum. This would be our lower quartile. This is our median. This is our upper quartile. And this is our maximum. So what would have to be the median?
The 80.
The 80. What is the max?
100. Or no, 95.
All right, so Satari. Angela has 20 homework grades. Do we know how many homework grades she actually has, Satari?
No.
Nope. So that's out. Angela's lowest grade is a 60?
No.
No, it's actually a 20. That's what you said a while ago. Angela's median grade is an 80?
True.
Good. Angela's highest grade that she ever scored was a 95.
True.
It is true because it counts by fives. And Angela's mean grade is an 80. Remember, a mean is an average, but earlier we said that we cannot calculate a mean by a box plot. So can that be an answer, Satari?
No.
Nope. Good. So what is the range of her work?
75.
Yeah, it's a 75 overall because it's from a 20 to a
95.
95. Good deal. Let's go on and do this one too. The box plot displays a summary of Angela's math homework grades for the last grading period. What do you know about her grades? Select all that apply. Let's break it down. It says half of her grades are between 20 and 60. Is that half? What do we say that would be? Braden, how many percent would that be? Remember at the beginning of class, I said that a box plot represents 100% and it's split into 4 sections. This is only one section. So how much is it actually representing?
Is it 25?
Correct. Since this is 25%, this cannot be correct. If it would have said 25, it would have been right. Half of her grades are between 20 and 80.
True.
That is true because this is another 25, and 25% plus 25% is 50%.
50.
Good. Half of her grades are above 80. Do y'all agree with that statement?
I do.
Because if this is 80 and that's the median, remember at the not the beginning, but about the middle of the class, I said anything to the right of the median makes up how many percent?
50.
50%. And anything to the left of the median makes up
50.
50%. Now, Devin answered this earlier, so I don't want him to answer it now. I want somebody else to see if they can restate what they said. What is the range of our data? Hadn't heard from Khalees. Khalees, what's the range of our data? How would we find the range? We take the max and we do something with it.
Subtract.
Correct. You take the max and subtract the minimum to get our range. So the max was 95. The minimum was 20. So to get our range, what are we going to do, Khalees?
Subtract.
Correct. We're doing 95 minus 20, which equals?
75.
So is it right or wrong?
Right.
Good. The mean of her grades is greater than the median of her grades. Can we calculate the mean with a box plot?
No, we cannot. So that is incorrect.
That is incorrect. Good. Do you see how the box plot tells you something about her grades are spread out? Yeah, she's not real consistent. I mean, most of her grades are kind of in this area, but every once in a while she bombs a test. Sometimes she gets an A. She's kind of all over the place. She probably needs to make sure she just stays focused instead of one day staying focused, the other day watching YouTube all day. Not working. Number 11 is where we're headed. All right. Vincent, go ahead and read this and tell us how to work through this problem correctly.
Drag the tiles to help Mark construct a box plot that represents these grades.
All right, before we can do any of that, what do we have to do with this data set?
Put it in order.
Great, so I want you to do that. So tell me what goes first.
Oh, name it, tell you
Yeah.
the order? Oh, okay. 65, 68, and then 72, and then 78, then 82 twice, and then 85, then 88, then 90, then 91.
Perfect. How many numbers do we have in all?
10.
10. So our data is split at 82. All right? So we need to find everything. We got to find the minimum. We got to find the maximum. We got to find the median. We have to find the lower quartile. And the what?
Upper quartile.
Correct. So I want to talk about the lower quartile and the upper quartile. I need everybody to understand that the lower quartile is the middle of the data from the minimum to the median. The upper quartile is the middle of the data from the median to the maximum. If you don't know that, write that down. I'm going to restate it one more time. The lower quartile is found by finding the middle of the data from the minimum to the median. The upper quartile is found by looking at the middle of the data from the median to the maximum. All right, Vincent, what is our median?
The way I did it was I just found the minimum and then the maximum.
Okay, let's start with that.
I just counted all the lines in between.
So the minimum is what?
65.
Okay. What is the maximum?
91.
Good. Now what?
And then I counted the little lines and I got 72 for the next one.
The little lines. Oh, smart. That works. I did it totally different.
I actually did it with the number set.
Yeah, I did too. I didn't do it that way. Good job, Vincent. Way to be able to use your brain, man. What's the median?
82.
Devin, how did
I
you
would've
get
never
your
thought
median?
to do it. I just, you said that it was split at 82, so I just
Correct.
82 was median.
So we do 82 plus 82 divided by 2, and that gives us 82.
Yeah.
All right. Now, on the lower quartile, there's 5 numbers. 1, 2, 3, 4, 5. The middle of that is 72. So that's how I get my lower quartile. So the way I get my upper quartile, there's 1, 2, 3, 4, 5 numbers. So I go directly to the center and I get 88. Or you can do it the Vincent way. 82 plus 6 is
88.
Good job, Vincent.
I would have never thought to do it that way.
Man, me either. I would have known it would have been wrong. You're
Like, I
smart.
would have just
Smart guy,
double mashed.
Vincent. Way to figure that out. All right. So this right here is the questions that I wanted to cover so that we would be prepared for our test. So as far as our video is concerned, this is going to conclude our video.